We're working on 9-4 multiplying special cases. Now, if you remember from the last lesson, 9-3, we learned about FOIL, which was our method to multiply binomials. First, outer, inner, and last. In this lesson, we're kind of learning shortcuts. We're still multiplying binomials, but they're special binomials, so they have their own special product and thus also a shortcut. So our first rule is the square of a binomial. So we're squaring this binomial a plus b squared. Now we know if we wrote that out, it would be a plus b times a plus b. The rule is that a plus b squared will always be a squared plus 2ab plus b squared, meaning that a plus b squared is the first term squared plus 2 times the two terms, a and b, plus the last term squared. And let's see how that works out if we use FOIL. So I want to see if a plus b times a plus b, which we know is the same as a plus b squared, will in fact end up being a squared plus 2ab plus b squared. So if we use FOIL, first, outer, inner, last, first times the first, a times a squared, a times b, these are the outer terms, a and b are the outer terms, so a times b plus ab. Then we do our inner terms, inner times the inner, b times a, which is plus ba. And then finally our last term, b times b, which is plus b squared. We know then we have to simplify. A squared has no other like terms, so it's simply a squared. ab and ba, those are the same thing, since a times b is the same as b times a. Just like if you did 2 times 4, that's 8, 4 times 2 is also 8. So we know that AB and BA are the same thing, so we actually have plus 2AB and then finally plus B squared. So you can see when we actually work it out using FOIL that we do end up with A squared plus 2AB plus B squared, which is how they ended up with this rule. Let's look at A minus B squared. The rule for A minus B squared is that you end up with A squared minus 2AB plus B squared. So if you notice, the only difference between these two products is this sign right here. Here it's a plus and here we have a minus. So when you have A plus B squared, all your signs are positive, or both your signs are positive. When you have A minus B squared, then your first sign is a minus and your second sign is a plus. But again, you'll notice it's A squared, 2ab and b squared. A squared, 2ab, and b squared. So you square the first term, a squared. Then you do 2 times your two terms, 2ab. And finally you do your last term squared, b squared. We can look at this using FOIL as well. So it's the a minus b times a minus b. And we'll FOIL it. First times the first, a squared. Outer times the outer, a times negative b. So it's negative ab. Inner times the inner, negative b times a, so negative ba, and finally negative b times negative b, which is plus b squared. Then if we combine like terms or simplify, a squared is again by itself. Okay, let's see if we can get this to work. A squared, negative AB and negative BA, we said before that those are the same thing. BA and AB are the same thing. So it's negative 2AB and then plus B squared. So again, you see we do end up with the same product as the product in the rule, and that is why the rule is what it is. So let's practice that on some real problems. Example 1 is squaring a binomial, which is the rule we just learned. So if we have y plus 11 squared, we know that's y plus 11 times y plus 11. Again, you could FOIL it out if you wanted to, but we're learning these shortcuts, so let's use our shortcut. So if we look back at the rule, we know we have to square our first term. Our first term in this case is y, so I'll square it, y squared. And then we do 2 times our two terms. So I have plus 2 times y times 11, and then finally plus, again looking back at our rule, we square the last term, b squared. Square the last term, and our last term is 11. 11 squared is 121, and I'll just simplify. 11 squared plus 2 times 11 is 22 times y, 22y plus 121. Now, the more you do this, you can skip this whole step right here, and you should be able to go directly to your answer, y squared plus 22y plus 121. I just put this here to show you what I was doing. Let's try one more. So again, we're following our rule. We're always going to do the square of the first term, a squared, 2 times our two terms, 2ab, and then the square of our last term. So let's try that again. Notice here that we have, it's a subtraction sign here, so we're going to have, this sign is going to be our subtraction sign. So first I'll square my first term, so it's 3w squared. And I'll put it this time, but again, you can skip this step. I'm just showing you what I'm doing. And then 2, so minus 2 times both our terms, times 3w and times 6, and then plus our last term squared, 6 squared. So when we work this all out, 3w squared, 3 squared is 9, w squared is w squared, negative 2 times 3w times 6, negative 2 times 6, negative 12, times 3, negative 36, negative 36 times w, negative 36w. And then finally, plus 6 squared, which is 36. Again, you can skip this step. The more you do it, you should be able to skip this step. I'm just showing it to you to show you what I'm doing. So let's try some quick checks now. We're going to do quick check 1, B, and C. Starting with B, this is an addition, so we know all our signs are going to be plus. And again, we're just following our rule. Our rule is square the first term, so 5y squared, plus 2 times both our terms, times 5y times 1, plus square the last term, 1 squared. So we get 5 squared, 25, y squared, and hopefully you remember this rule from back in chapter 8, where when you square this term, everything inside the parentheses has to be squared. Plus 2 times 5y, which is 10y times 1 is 10y, plus 1 squared, which is 1. Let's try another subtraction problem. Same rules. The only difference is instead of 2 plus signs, you know that first sign has to be a minus sign. So square your first term, 7m squared, minus 2 times both your terms, plus your last term squared. So we end up with 7m squared, 7 squared, 49m squared, negative 2 times 7n times 2p, so 2 times 7 times 2, 2 times 7 is 14, times 2 is 28, it's a negative 28, m times p is mp, and then plus 2 squared is 4, and p squared is p squared. This one was a little different since we had those two different variables, but remember you can always multiply unlike terms, but you can never add or subtract unlike terms. So we end up with 49m squared minus 28mp plus 4p squared. And we have no like terms, so we are finished. If you want to go back and check using FOIL, it may help you to understand and to see that you do in fact get the same answer with FOIL as you would using our new little shortcut that we've learned. All right, let's move on to example 3. If you notice, we're skipping example 2. That's that real world example. Moving on to example 3, this is using mental math. So you may not understand where this rule might come in handy for you, but actually it will come in handy when you're trying to square really large numbers. So we're going to change 81 squared into something that looks like this, into a binomial. So instead of 81 squared, I'm going to do 80 plus 1 squared. And isn't that the same thing? 80 plus 1 is 81 squared. So I really haven't changed it, but now I can use my rules that I just learned for squaring a binomial to find 81 squared without even having to use a calculator. So my rule says square your first term, so 80 squared, plus 2 times both your terms, plus your last term squared. Again, I'm doing all this without a calculator. So 80 squared, 8 times 8 is 64, 0, 0, plus 2 times 80 is 160 times 1, so 160, plus 1. So then we add all these together, 6,400 plus 160 plus 1. 6,400 plus 160, well, that's 6560, and then plus 1, 6561. And you can check that on your calculator. You should get 6561. Let's try one more using our new technique, 59 squared. Okay, so you could do 50 plus 9, but then you're still using a rather large number. So instead of doing that, let's try to keep our numbers easy. Instead of doing 50 plus 9, I'm going to do 60 minus 1. Same thing with up here. You could have done 90 minus 9, but those numbers are a lot harder to work with than 80 plus 1. We like this 1 back here. That really helps us out. So same thing here. You could do 50 plus 9, but let's use the easier numbers, 60 minus 1. So now we're going to use that rule for when we square a binomial and you're subtracting the two terms. So just remember the only difference is that first sign is going to be a minus sign. So we still square the first term, 60 squared, minus 2 times the first term times the second term plus the second term squared. And again, like I've been saying this whole time, you can skip this step. The more you do this, the more, the easier it'll get and the better you'll be at it, and you can simply skip this step. But for now, I'm going to show it to you. So 60 squared is 6 times 6 is 36, and then you tack on those two zeros, because 60 and a 60, you have the two zeros. 2 times 60 is 120 times 1, 120, so minus 120, and then finally plus 1 squared, so plus 1. So let's see here. We have 3,600 minus 120, so I'm thinking 3,600 minus 100, that's 3,500, minus 20, that's 3,480, plus 1, 3,481. And you can check that in your calculator as well. So let's try some quick checks. Let's look at quick check 3, C, and D. Find each square using mental math. So now the numbers have gotten a little bit harder. Again, there are two different ways you could do this. You could either do 90 plus 8, or you could do 100 minus 2. I like to use that smaller number. So I know that 100 is bigger than 90, but this number is no problem. It's that second number that you want to worry about, and this 8 is too big. So I'm going to use 100 minus 2 squared. So we have 100 minus 2 squared. We square the first term, 100 squared. 1 times 1 is 1, and then I know I have 1, 2, 3, 4 zeros, because 100 times 100, you end up with 4 zeros. Minus, since this is subtraction, we know that first sign has to be minus, and this is 10,000 by the way, minus 2 times 100 times 2 plus our second term squared, 2 squared. So we end up with 10,000 minus 2 times 100 is 200 times 2, 400, plus 2 squared is 4. So I get 10,000 minus 400, that's 9,600. 9,600 plus 4, 9,604, or 9,604. All right, let's try another one. So you have two options here, 200 plus 3, or you could do 210 minus 7. Ooh, I don't think so. That doesn't sound very fun. So let's do the 200 plus 3. 200 plus 3 squared. So we square the first term, 200 squared, plus 2 times the first term times the second term plus the second term squared. So we end up with 200 squared, 400. Oh, sorry. 2 times 2 is 4, 0, 0, 0, 0. We end up with 4 zeros plus 2 times 200 times 3. 2 times 200 is 400 times 3 is 1,200 plus 3 squared, which is 9. And now we need to add all of that up. See, put my comma here and I have my comma here. So I know I end up with 4 and then 1 and 0, so it's a 1 there, 41. And we have the 2, 0, and our last number is that plus 9. So it's 1,209 plus 40,000, 41,209. All right, we're almost finished with this lesson, but we're going to continue it in the next video. So we'll finish up with example 4 and example 5.